Hello everyone, welcome to solve this nice math Olympiad exponential equation problem. So here we have 7 to the power of x minus 6 to the power of x is equals to 13, and we solve this problem for all the values of x. So here first we need to find all the roots of this equation, and at the last we will verify that which of the roots are solution and which of the roots are extraneous root. Further in this question I can explain the solution of this problem by geometrically representation. Okay, so please watch this video at the end. And further in the next step we move towards the solution of this problem, and the very first thing we are going to do is first we need to divide both of the sides by 6 to the power of x. And when we divide both of the sides by 6 to the power of x, it will be written as 7 to the power of x divided by 6 to the power of x minus 6 to the power of x divided by 6 to the power of x is equals to 13 divided by 6 to the power of x. And now further in the next step we have this 6 to the power of x and this 6 to the power of x are cancelled out by each other, and here we use the nice exponential law. You know about that. If we have a to the power of m divided by a to the power of m divided by b to the power of m, so it is equals to a divided by b and its whole power m. So according to this rule, we combine the exponent of these two terms, and after using this rule, our above equation is written as 7 over 6 to the power of x minus 1 is equals to 13 divided by 6 to the power of x. So here for move further, we first explain a nice fact related to the exponential function, so which is this fact is very helpful to solve this type of questions. And here further you know about that if we have some exponential function is a to the power of m, so there are two possibilities. The first possibility is that if our a is greater than 1, then we say that the whole function a to the power of m is increasing function. And if the second possibility is that if our a is less than 1, then we say that a to the power of m is decreasing function. Okay, in the next step, so now you see here we need to check the base of this term, and we check that is this less than 0 or less than 1 or greater than 1. So that for verification of 7 over 6, here we clearly say that 7 is always greater than 6, and if this 7 is greater than 6, this implies that 7 over 6 is greater than 1. So if 7 over 6 is greater than 1, so it means that the base of this term 7 over 6 is greater than 1, so it means that 7 over 6 to the power of x is increasing function. So this implies that 7 over 6 to the power of x is increasing function. Okay, because its base is greater than 1. And also you see here when we subtract an increasing function with 1, so it will remains an increasing function. So this means that our left hand side becomes increasing function. Okay, so here first we need to check both of the sides, which one is increasing or decreasing, and then we make the graph of this equation and we get the values of x. Okay, so now here we need to check our right hand side, and here we copy down the right hand side is 13 over 6 to the power of x, and first we check that is this increasing or decreasing. If you see on 6 to the power of x, and you see here clearly the base of this term is 6, and 6 is greater than 1. This means that 6 to the power of x is increasing function. Okay, so 6 to the power of x is increasing function, and when we divide any number with increasing function, it will becomes decreasing function. So 13 divided by 6 to the power of x becomes decreasing function. So this whole function becomes here decreasing function. And now we see that our left hand side becomes increasing function and our right hand side becomes decreasing function. So if we make the graph of increasing or decreasing function, so the graph of increasing function looks like in this way, and the graph of decreasing function looks like in this way, in this form. So also you see here, an increasing function or decreasing function are always intersect only one point. So this point is called the solution of this problem, or this point be the value of x. So here in the next step we need to find the value of this intersection point. Okay, so for this we need to copy down the given question statement here, and the given question statement is 7 to the power of x minus 6 to the power of x is equals to 13. So here we get the point of intersection on both of the sides. So here we find the value of x by inspection. So that first we take x is equals to 0, and when we take x equals to 0 and we put on the left hand side, it will becomes 7 to the power of 0 minus 6 to the power of 0 is equals to 13. So this implies that 7 to the power of 0 becomes 1, and 6 to the power of 0 is also becomes 1 is equals to 13, and this will be written as 0 equals to 13. This shows that both of the sides are not equal, and it means that x is equals to 0 is not satisfied given question. And now we verify x is equals to 1. When we put x is equals to 1, it will become 7 to the power of 1 minus 6 to the power of 1 is equals to 13, and 7 minus 6 becomes 1 equals to 13. So this is also not possible, and when we choose x is equals to 2, so it will be written as 7 square minus 6 square is equals to 13. And here you clearly see that 7 square becomes 49, 6 square becomes 36 is equals to 13, and here we will get 13 is equals to 13. So this shows that both of the sides are equal. It means that the value of x is equals to 2 is satisfied our given question statement. So finally we have the solution set of this problem is x is equals to 2. This is the final answer, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.